you understand how to make calculations for the thermal energy lab 12. If you can recall, we did a lab where we had 3 cups, and we labeled the cups 1, 2, and 3. In cup 1, we had a large brass cube, and the mass of the cube was about 270 grams. Okay. The small brass cube, the mass was about 68 grams. And then the aluminum cylinder, it had the same mass as the small brass cube, 68 grams. About. Your data was a little bit different. All right. Okay. So these two had a mass that was the same. Right? And because those two have a mass that was the same, there was something else that we changed between them. Right? One was brass, and one was aluminum. So the type of material changed there. Between cup 1 and cup 2, we changed the mass, right? So the mass for these two is 270 versus 68. Okay. So we're doing 2 experiments. We're testing 2 different things. One thing that we're testing is how does mass affect energy transfer? And the second question that we are asking is how does material affect transfer of energy? Right? So to test mass, we are comparing these two. In order to test material, we are testing cup 2 and 3. We're comparing the results of 2 and 3. When you did the experiment, you heated up the objects so that each object was the same temperature. Since the object was in, to begin with, it was in a hot bath, and there were those fish stones at the bottom. We put them in a hot bath of water, and the water was boiling. So since it was boiling, the temperature of the water was 100 degrees Celsius. Naturally, what substances do is they reach equilibrium because they are constantly transferring energy from the warmer to the cooler. So the water transferred energy to the cube until the cube reached that same temperature. And we left it in there for about 5 minutes, so theoretically it should have reached equilibrium. So not just the water was 100 degrees Celsius, so was the object. And the object was 100 degrees. So we heated that up. That was step 1. The next thing we did was we took each of the objects and we put it into the cup. The cups each had, all right, so the water in each cup, 125 milliliters. And this is one thing that was helping us to perform a valid experiment. The amount of water was the same. Not only the amount of water was the same, also the type of water. And then the other thing about the water that was the same was the initial temperature. temperature was the same. The initial temperature of everybody's cup was different. I'm just going to show you an example where the initial temperature starts out to be the initial temperature, 17. So they should have all started out to be the same. All right? So every 30 seconds for 5 minutes, you collected data, and in the end, you had different temperatures in each cup. So the goal is to answer our two questions. How does mass affect energy transfer, and how does material affect energy transfer? When you completed the experiment, you were instructed on your lab packet to draw interaction diagrams for each cup, and then also calculate the amount of thermal energy gained for each cup. So using the large graphs from cup 1 as an example, cup 1, an interaction diagram shows what was it that lost energy, and what was it that it gave the energy to? Through what method? In each of the examples, because the object itself was warmer than the water, and it was transferring the energy through conduction, the object that was losing the energy is the brass for cup 1. And what was gaining the energy? Well, we had it in water, and that's what we were measuring the temperature of. Through conduction. In order to calculate the amount of energy that was transferred, you have to figure out the information that is needed to solve your problem. So the formula is mass times change in temperature times specific heat. If the question says how much energy was gained, which energy was gained, you're looking at the substance that is on the right of the interaction diagram. So the energy gain is the material. We have to know the material. We have to know the mass of the material, the change in temperature, how much did it increase, and also its specific heat. The material that gained energy again was water. The mass of the water, we had 125 milliliters, and we learned that the density of water equals 1 gram for every milliliter. So if we have 125 milliliters, that's 125 grams. But mass has to be in kilograms. So we have to convert. 125 grams equals how many kilograms? To convert from your base unit grams and go to kilograms, that's 1, 2, 3 to the left. 1, 2, 3. we end up with 0.125 kilograms. And the change in temperature is the final temperature minus the original. So in your data table, you had 0.0, it's your initial temperature. It should have been the same for all 3 cups. In mine, it was 17 degrees Celsius. And the final, you know, all this time in the middle, and then the final temperature for mine is 29.5. Oops. So after 5 minutes, 29.5 degrees Celsius. So our change in temperature, final minus original, 29.5 minus 17 degrees Celsius. So the change in temperature is 12.5 degrees Celsius, and the specific heat of water is always the same. It's always 4.18 kilojoules per kilogram degrees Celsius. And again, what this means is that for every 1 kilogram, it takes 4.18 degrees Celsius, or excuse me, 4.18 kilojoules to raise the temperature by 1 degree Celsius. Once you have all of this information, you can use this to calculate. So energy equals mass times change in temperature times specific heat. We don't know what energy is yet. We know what the mass. We know that the mass is 0.125 kilograms. The change in temperature, 12.5. And the specific heat of water is 4.18 kilojoules for every kilogram degrees Celsius. Now you can cancel out what is repeated. So on the top and the bottom we have a kilogram, and then there's also degrees Celsius repeated. There's no kilojoules on the bottom, so we can't cross that out. That will be our final unit. The only thing that's going to be different between your information and mine is this change in temperature. In fact, that's what's going to be different from cup 1, 2, and 3. Everything else is going to be exactly the same. The 125 and the 4.18. So multiplying this out times 12.5 times 4.18 is 6.53 kilojoules. All right. So you're to be doing this for all 3 cups and then answering the analysis questions. The whole point of this experiment is to find out what is it, how does energy change when mass is different? All right, so question number 2 asks, how does the mass change? What is the relationship between mass and energy? Okay, so does a lesser mass transfer more And then the other thing that we're looking for is between cup 2 and cup 3. The other thing we're looking for, does the amount of energy that is transferred, does energy transfer, well, how does energy transfer change when the type of material is changed? Does it matter whether it's aluminum or brass, or is it just mass that matters? Does energy transfer change when different conductors, types, or materials of conductors, different types of conductors are used? So a simple application of this would be for chefs, or if you cook at home, would be, what is the most efficient kind of pot? Is it, what kind of material? Should it be iron, brass, or aluminum? Right, copper. Right. This is a good application to this. What type of material is best for conducting? Which one will make my water boil faster? Okay. So these are the two questions that you're looking for in the end. You can rewind and fast forward to see the calculations a little again.